Hey guys, I hope by now you are pretty familiar with the parent functions. And so now what we're going to learn how to do is to take those parent functions and transform them in some way. That means horizontally and vertically shifting them, horizontally and vertically stretching and shrinking them also.
That's perfect. Oh! No! My phone! That's why you always wear a helmet. Shotgun! No! Shotgun! Dude, wrong car. Woo! Here we go! Yes! Woo! Slicing apples. Brad, go ahead. Nice. That's really why I like multiplication, because it's
I'm
really...
gonna go check on the laundry.
Okay. Zach, you wearing any green today? Time for a little pinch. I got green. Hey, just in time, turning water into ice. Nice. No, that's not checkmate, Michael. You can't do that. I'll show you. No. Hey, those are mine.
Okay, if you can find the workbook page that matches this 1.2 page, we're going to go through a few of the transformations together, just so you can get the idea, and then in class we'll practice them. Okay, so what we're looking at here are pieces of the function. So once you spawn that parent function, you're looking at the outside of it either being added or subtracted, and that tells if it transforms in some way. Or in this case, where the number is on the inside of the function. Okay, so look at the difference. You do want to be able to tell if a number is on the outside or the inside of a function. You also want to be able to see this positive or negative on the outside, because that's going to make a difference. All of those things are different translations. Okay, so the first one we're going to talk about is a number that's on the outside. Anytime you have a number on the outside, hopefully you figured this out in class today, but it's going to take that parent. So let's say, so here's our parent here, oops, and it's going to move it up in this case because there's a plus k. So we're going to move up 2 places here. Okay, so the one on the bottom, if it was that parent function again, but minus 2 on the outside, that means it's going to move down 2 places. So you no longer really have to make an f of x chart. If you can memorize these things, it will be a lot easier to get the look of that graph. Okay, so the next one we're going to talk about is inside the function. So what happens when it's inside? Anything that's a horizontal, meaning left and right, shift or stretch, is always the opposite of what you think. So when it says, like in this case, it says minus 2 on the inside, that is actually going to be right 2 places. Okay, so let's see. So here's the original graph. And then what happened was it moved right 2. Okay, and we figured that out by doing a whole bunch of x and f of x charts and realizing over time that that's what's happening, is that on the inside it's moving to the right. So the same thing happens for something like this, where we have the we have the plus 3 on the inside. That means it's going to be the opposite of what you would think, which is it's going to move left 3 places from the origin. Okay, so then the last one we're going to learn today, there are a couple more, but the one we're going to learn today is with this negative on the outside. The negative on the outside means it's going to reflect, you can write this in your notes if you need to, reflect over the x-axis. So instead of being, let's see, here's the original function again. That's the original absolute value of x, and this works for every parent function. All the transformations are the same. So if you learn it for absolute value today, it's going to be the same for x squared, going to be the same for square root of x. All right, and so what happens is that just means it flips upside down. So instead of a facing up V, we have a facing down V. Okay, so kind of think about these things that I said now, and in your workbook you should be able to find this question, but what happens when it's on the outside of the function? What happens when it's on the inside of the function? And what happens when you have a negative on the outside? Okay, so outside the function, it's going to move, if it's positive, it's going to move up. If it's negative, it's going to move down. And of course, we're saying from the origin is where we're getting that from. Okay, so on the inside, if we have a plus, that means it's moving left. Again, that's the one that's opposite of what you think. When it's minus, it's moving right. Okay, and then this last one here is going to be the negative on the outside, means it flips over the x-axis. All right, so let's practice this down here. It says compare the graph of each parent function. You don't have a calculator with you at home, so we're just really just going to describe what happens. So the parent function, of course, in this one is the square root of x. And then so what this one's going to do from the square root of x is move down 4 places. So we can kind of visualize that graph. It's going to be the square root of x graph, but it's going to move down 4 places. Okay, and that takes away from us having to do a whole lot of x and y, x and f of x graphs, charts. Okay, so the next one is on the inside. It's a plus on the inside, and so we learned over here if it's on the inside and it's a plus, that would be left. Okay, so that means we're going to move left 4 places. So we're going to still take that basic square root of x graph, but we're going to move it left 4 places. Same shape, just moves left. All right, so let's try this again for the negative on the outside. That one means it's going to flip over the x-axis. So that would look like, again, here's the original, and that would look like this. Okay, so flipped upside down over the x-axis. All right, and of course for these last 3, you're welcome to pause the video and then come back to it after you try it. There's nothing wrong with that. I actually suggest it. When you're ready, then you can play the video again. But this one's going to be the x squared graph, which is a parabola, and it's going to move up 1. So it's going to be the basic parabola, and we're going to move it up 1 place. Same shape. It looks a little bit thinner there, but that's just error because I don't have a actual graph in front of me. We're just kind of sketching for these. Okay, so this one's going to be the same x squared graph, but it's going to move right 1 in this case. So here's the original graph, and we're going to move this sucker right 1 place. Okay, and then the last one is negative on the outside, which means it flips upside down. So if I have this kind of a original shape, then I'm going to flip it over the x-axis this way. And when we get really good at this, we're going to put all of them together. Okay, so here's where you want to kind of look when you're reading these. Like I said, we're going to put them all together. So here's where you get if it's the original or if it's the flip. So it's going to flip x-axis if there's a negative there. So if it's a positive there, it's just the regular parent function. All right, the other ones that we learned today were on the inside of the function. If it's positive, remember again, that means it moves left. If it's negative, it's going to move right. Okay, and then the outside function, we talked about if it's positive, it's going to move up. If it's negative, it's going to move down. Exactly what you would think. Now this B here, we're going to actually save for the next section. Or in class tomorrow, depending on when we get to it. But we haven't talked about the A or the B. We've only talked about the positive and negative, which go here with the flipping. The A and the B are going to stretch and shrink. So right now, for tonight, I really just want you to be focused on the three that we discussed in the section, we will eventually get to the A and B and then put them all together. That's when it's really fun.